Hello student, the question says, for ensuring dissipation of same energy in all three resistors R1, R2, R3 connected as shown in the figure, their values must be related. It is asking how R1, R2, R3 must be related. Let us try to solve this problem. So we will take this circuit and the input voltage is given as V in. These two are in parallel. We can solve this problem using current method and voltage method, but I prefer to solve it in voltage method. Imagine the voltage across R3 is V. Then the voltage across R2 also must be V only because both of them are in parallel. So what is heat dissipated by the second one is equals to heat dissipated by the third one. So V square by R2 into T is equals to V square by R3 into T. So from this we can clearly write R2 will be equals to R3. So straight away we got R2 equals to R3. Let me call this as R for convenience. So I can redraw this entire thing. In place of R2 and R3, I can just draw R and R now. Okay. So once we draw R and R, imagine current I is flowing in the circuit. Because of this, current I started to flow in the circuit. And when current I is flowing, since both the resistors are exactly equal, in this half current would go, in this half current would go. So what is the heat dissipated across 1 is also equal to heat dissipated across 2. So from this I can write I square R1 into T is equals to I by 2 whole square into R2 into, this is R2 into T. So from this we will get R1 is equals to R by 4. So R2 must be equal to R3 and R1 must be equal to R by 4. So R2 must be equal to R3 and R1 equals to R2 by 4 or R3 by 4. Anything is fine. So the correct answer for this would be option C. But is this the only way to solve this? If I told I don't want to use current, if somebody is like, I don't want to use current only, I like only voltage and I want to solve this problem only with voltage. So let us try on one more way to determine R1 is R by 4, but this is quite lengthy. Suppose if this is voltage V and this is voltage V, if I find R effective, across both of them, so I will get the R effective as R by 2. And the voltage would be, if individually each one has V voltage, their R effective also would have V voltage only. And we have current I flowing. It is irrelevant. Like right now, we are not going to use current. Let me call this voltage as V1. Okay. In series, their R effective is in series. So in series, I is equals to constant. So we can say voltage is proportional to resistance. The problem is completed here, but we are just looking at an alternate way also. So voltage is proportional to resistance. I can write V1 by R1 is equals to V divided by R by 2. So I can call this as 2V by R. So V1 by R1 equals to 2V by R. So from this V1 equals to 2V by R into R1. So this is one thing. Now what is the heat dissipated across this? H1 would be V1 square divided by R1 into T. This heat must be equal to V2 square divided by R2 into T, because the author is saying the heat must be same. So based on this, V1 square would become 4V square by R square into R1 square into 1 by R1. I will cancel Tt is equals to Vt square. We know it is V square divided by R2. So if I cancel the terms V square, I can cancel. And R2 is nothing but my R. So 1 R would cancel. One more R here. R1 we can cancel. So we basically get R1 equals to R. Why I solved it in such a lengthy method, it is to tell you that a current electricity problem can be solved in many methods. It is like solving a puzzle. So how to utilize that puzzle? Generally, remember there is a very simple rule. If there are in parallel, use voltage as the main thing. If they are in series, okay, you start with voltage. If they are in series, use current as the main thing and then try to solve the problem. I hope you understood how I have solved. Thank you.